Okay, good evening. Group 2, we will be discussing integral calculus this evening. My name is Selma Bayton.
And I am Junette Leon.
And Agnes Timor.
The course description is integral calculus consists of 4 parts: integral, antiderivative, introduction to differential equation. Number 2 is transintegral functions, technique of integration, and application of integral. But for this presentation purposes, we are going to focus more on number 3, which is the techniques of integration.
During the lesson, we will apply Bloom's taxonomy to ensure that students are able to integrate polynomial, power, and basic trig functions using the methods of substitution, trig identities, partial fractions, or integration by part. Students will also be able to recognize integration as the reverse process of differentiation, as well as to use integration to find the average value of a function over an interval. Next, please. For prior knowledge, as we begin working with integrals, it is beneficial to maintain students' proficiency with differentiation to support learning integration. Students will also need to have prior knowledge of functions, differential calculus, pattern analysis, area, distance, speed, and time, as well as limits. At this point in calculus, the students have been introduced to the big ideas. They have studied slopes of tangents and how to compute and interpret those slopes. They have also studied what the area under a function can tell. Now they're ready to transition from differential to integral calculus and frame the big picture of their progress through calculus. We also employ 2 GeoGebra applications to have the students review the concepts of slope and derivatives while working on the prior knowledge. Next, please. Instructors will use GeoGebra to deliver the content. GeoGebra is an interactive geometry, algebra, statistics, and calculus application intended for learning and teaching mathematics and science from primary school to university level. The students will be guided through a number of activities using this software. The lesson problems with GeoGebra will include activities on integration by substitution, integration by parts, and integration using partial fractions. Next, please.
Throughout our lesson planning, we use TPAC. TPAC, it has 7 components, and it's a systematic way to prepare, execute, and teach, and making sure that we use technology throughout the lesson. TPAC is an understanding of how teaching and learning can change when we use these technologies. It is very student-friendly and makes sure that it's accessible for students. Students are able to access the resources regardless of their financial situation or economic background, which means we use very few resources and base our lessons on GeoGebra. Next, please. Pedagogical knowledge. We, throughout our lessons, used 21st century skills. It means that our lesson is based on research, digital citizenships. It's making sure that involves communication and collaboration. As well as we make sure that using TPAC, students will gain information from a variety of sources. Next, please. Throughout our course, we learned calculus from a historical perspective. We have learned the Babylonians, how they made their brown clay tablet that actually fits in the palm of our hand. We looked at the Egyptians with their measurements. Then later on, the Golden Ages in Greece. However, all these ancient mathematicians were not able to shine light onto infinity, and that was seen in Zeno's paradox. Obviously, Achilles actually passes the tortoise, but they were not able to show that using mathematics. Later on, with many very famous mathematicians, Descartes, Fermat, Newton, Leibniz, and so on, laid down the framework of calculus that we use today. However, it doesn't mean that integral calculus is done, the framework is done, because it has a never ending discoveries even today. Next, please.
Method of integration. There are 5 methods of integration that we will discuss today. The first is integration by substitution. Integration by substitution is a method used for evaluating integrals as well as antiderivative. It's actually also known as U substitution, and a better way to say it is like to do the chain rule reversely. Second is integration by parts. Integration by part is a special mode of integration that is often used when two function is multiplied. So the factors of two integrals. So basically it's actually, you take the first function, you multiply by the integration of the second function, then you subtract the integration of the differentiation of the first function, then times it by the integration of the second function. Thirdly is the integration by using the trig identity. It allows the integrals to be written in an alternative form, which is much easier to integrate. So we use, and then we're going to use a U substitution. Fourth is the integration of some particular function. There's a list of these particular functions. For example, if I'm doing an integration of d of x divided by x squared minus a squared is equal to 1 divided by 2a log the absolute value of x minus a divided by x plus a plus some constants. And then the last one is integration by partial function. And basically go back to algebra 2 when we decompose the algebraic function in partial function by some reverse process. Formative assessment. So the goal of formative assessment is to monitor student learning to provide ongoing feedback that can be used by instructors to improve their teaching and by students to improve their learning. So basically, we're going to have a GeoGebra activity that it's more formative rather than summative, for the kids to decide which method they would use. There are 5 integration here. And and the integration by parts is an applet that we use where you give an example and then they have one question that the kids will do by themselves. And the applets work as so as you tells you exactly what to do, and then it gives you the answers. And it just give you an example, and it prompt the students of how to handle a situation. And then the practice is actually an integral that they have to do themselves. Hereby, the teacher will monitor the students to make sure that they use the correct method, or usually they work in group. And after they do the integration, they just show your answer, and it will actually give them the answer and let them know that they're correct or they're wrong. Okay, so that's an example of our GeoGebra using some formative assessment. We do the same thing with summative assessment. This one is actually a cumulative of all the different methods, and the students would not have an example of how it's worked. They're going to actually walk it by themselves. And this is going to be also a GeoGebra activity, mostly a multiple choice option they're going to use for this particular activity.
Throughout the lesson and with the help of the assessments, the teacher will check that the students are able to integrate polynomial, power, and basic trigonometric functions using the methods discussed. The teacher will also check the understanding of that the students understand the relationship between integration and differentiation. At the end of the lesson, the students will demonstrate mastery of different integration methods, including the substitution method, trig identities, partial fractions, as well as integration by part. They will also be able to show they can integrate different types of functions like polynomial, power, and trigonometric functions. Next, please.
Integral calculus has a great future. Integrals are a powerful tool to help us understand and model the world around us. I believe that the future of calculus lies improving on former discoveries like surface area and volume, mass and work, growth and decay models, the hyperbolic function, hanging cables, catenaries, and so on, including engineering, architectural, space exploration. However, the future of calculus is going to be more into machine learning, artificial intelligence, neural networks, as well as in healthcare. For example, patient diagnosis, epidemiology, calculate the rate of disease spread, or even in cardiology, blood flow, or cancer treatment, monitor tumors. So again, as integral calculus will improve on former discoveries, however, it's going to continue to evolve and expand. Next.
And here's a list of resources of reference. Thank you very much.
Thank you. Thank you for listening.
Thank you for listening.